So this section is called 6.5, the brute force algorithm. So brute force is one of the three different algorithms or ways, strategies we're going to learn how to solve a traveling salesman problem. This method has 3 steps. Step 1, you want to start at your home location. If the graph and the problem says to start at A, then you start at A. For the example we have with Adam, he's starting in Greensboro. We're going to use G for Greensboro. Step 2, you're going to calculate the cost of each circuit. So as you'll see, when you have a lot of vertices, you're going to have a lot of circuits. That's the downside to this method. Step 3, you pick the lowest one. So 3 steps in the brute force algorithm. So quick note, remember from our example with Adam in the traveling salesman problem, there are 5 different vertices. I'll show you that graph again. There are 5 different vertices that he's trying to go visit. G for Greensboro, W for Wilmington, C for Charleston, A for Atlanta, and K for Knoxville. So he's trying to go visit those 5 different locations. So 5 vertices, if you want to first figure out how many circuits you're going to have, remember Hamilton circuits is found by taking your n minus 1 in parentheses factorial. N stands for vertices. So if you have 5 vertices, 5 minus 1 is 4, and 4 factorial gives you 24. So in working this problem out, we're going to write out 24 different circuits. But take a deep breath. Don't worry, because really we talked yesterday about mirror circuits. And so a mirror image circuit is the same thing as a regular circuit. So for example, if Adam is flying Greensboro to Wilmington to Charleston to Atlanta to Knoxville and back to Greensboro, that would be exactly the same if you were to fly counterclockwise and go Knoxville first, and then Atlanta, and then Charleston, then Wilmington, and then Greensboro, because the prices in this example are exactly the same if you fly Greensboro to Wilmington or Wilmington to Greensboro, it's $185. So really, there's 24 total circuits, but that includes the mirror images. So really, take a deep breath, because we only need to list 12. So here's what I want you to do. I want you to make 2 columns on your page. You're going to make a column for route and a column for total cost. And what I'd like for you to do is pause the video and see if you can come up with all 12 different routes. Okay, hopefully by now you have paused the video and unpaused it. You have listed out your 12 different routes. Let's check to see what you have. So my routes are listed in this particular order. The order that you list them in really doesn't matter, but here are the routes that I have. So what this means, for example, is this means Greensboro, Wilmington, Charleston, Atlanta, Knoxville, Greensboro. Route 6 means Greensboro, Wilmington, Knoxville, Atlanta, Charleston, Greensboro. You'll notice that you have GWC 2 times. So GWA shows up twice, GWK shows up twice, and then you switch your first and second letter. So hopefully you had those different circuits. The order that you list them in doesn't matter, but hopefully you have all 12 of them. And I know that when I got to around 6 and 7, I got super confused. I started thinking, wait, did I use that one? Have I not used that one? And it can be very confusing. That way it helps me if I kind of keep some kind of order and write them out like this. On any kind of quiz or test, final exam, if we get to that at the end of the year, you will not have to do a problem where you have this many vertices. And doing this one as an example, so everyone else from this point forward is going to seem a lot easier. So what we now want to do is we will now calculate the total cost. So again, pause the video and find for me what is the total cost of each of these different routes. You're going to add up the numbers on all the different edges. So for example, Greensboro to Wilmington was $185, plus Wilmington to Charleston was $121, plus Charleston to Atlanta was $174, plus Atlanta to Knoxville was $199, and then finally Knoxville to Greensboro was $133. Add all those numbers up and you get $812. So please pause the video and see if you can come up with the rest of those numbers. Hopefully by now you have come up with most, if not all, of those numbers. I'll show them to you now so you can see those. As you can see, they have a pretty wide range. You have some numbers in the 800s, you have some numbers in the 700s, you even have a number in the 600s. So as you're writing those down, true story, when I first started teaching discrete, I didn't really know what I was doing and how to do this problem. And so Mr. Key came in to observe me. And while he was observing me, I had my class do this exact same problem. And I was like, all right, go ahead on your own and figure this problem out. And what they did was they started getting really frustrated. Maybe you didn't even pause the video because you were like, this is way too much work and too time confusing. It's way too confusing to know which ones I have and haven't done. If that's you, I hear you. I may not have paused the video either. So these numbers right here are for the routes and the for how long or what the price was for each of these. And it can be very confusing when you're listing all of them out. When Mr. Key came in, it was about 20 minutes it took us to figure out this problem. And by the end, my students were so frustrated and they were like giving up and like throwing things at me because they were so angry that they had to spend 20 minutes on one stinking problem. But here's where I think there's some real life application to it because 20 minutes is a lot of time. And again, you're not going to be asked to solve any problems in this class that will take you 20 minutes. However, let's say this is a real problem for you and Adam actually came up with this problem because this is a real situation for him and he sat down and did the 20 minutes of work. So what he figured out was this. It took about 20 minutes, but Adam was able to save and if this was his numbers, you're able to save about $201 because notice your very cheapest route is $676. That's your lowest route you have on the entire graph. The most expensive one is route number 6. It's $877. So if Adam, like I said yesterday, in that example, he was given an $800 stipend. If that was the case, then if he chose route number 6 by accident, or maybe because he was too lazy to do anything else, he would have to pay $77 extra. If he was really lazy and just said, you know what, I'm just going to go clockwise, he would pick the first route, he would have to pay $12. However, if he picks this route right here, route number 11, he's going to pay $676. Actually, he gets an $800 stipend, so he's going to get over $100 back. That is almost a $200 difference, just over $200 difference between these two numbers right here. So if you do the math on that, it took 20 minutes and he saved $200. That's about a $600 per hour problem. You may know this already, teachers don't make $600 an hour. I would love to make $600 in an hour. So this was me, I would sit down and figure out the work because it's worth it to save $600 in an hour or $200 in 20 minutes. But again, maybe when you work in sales and you have lots of money, maybe the 20 minutes is more valuable to you than the $200. There's pros and cons to this method. This is the last section. The pro is that it's optimal. In other words, you are always going to find the lowest cost. Always, always, always. You're always going to find the lowest cost because you list them all out. Because you list out all 12 routes plus the mirrors, 24 total routes, you're going to have every single one listed. So you're guaranteed to always get the lowest one. It is a pro. It is the only method we use where you're always going to find the lowest one. The con, as you probably have figured out already, is that it is not efficient. It takes a lot of time. The problems that we're going to do in class are going to have 3 and 4 vertices. We're not going to do problems with 5 vertices. But like I said, doing a problem this difficult will make everything else seem a little bit easier. But it is not efficient. It can take a lot of time. It won't take as long to do problems with 3 vertices or 4 vertices, but it can take quite a bit of time. So that is a con of this problem, is that it is not efficient. But the pro is that it is always, you're always going to find the lowest price. And that is how you do the brute force algorithm. We have 2 more algorithms to get to, which we'll cover tomorrow.